I have a test on Monday, so I have a giant packet full of problems.
Okay. We can do however many of them as you want. If you want to go beyond a half hour today, that's fine.
All right.
Okay. Let's start wherever you'd like.
Start by completing the square.
Okay.
So x squared minus 14x plus 1 equals 0.
Okay. Now, completing the square and solving the equation.
Yeah.
Okay. If we're going to do that, if we were completing the square in order to put it into vertex format, we would leave this 1 on this side of the equation. And the reason is that vertex format looks like this, x minus h squared plus k. So everything's on the same side of the equation. However, if we're completing the square in order to solve it, I want the 1 on the other side.
All right.
Okay, so let's do this as step 1. And you'll understand why after we complete the square. Okay, so how do we complete the square?
Don't you divide 14 by 2 and then square it?
And then add it or subtract it?
Add it?
Yeah, because after you square it, it's positive. It's never going to be negative. Even though we had a negative 14 that we took half of, once we squared it, it became positive. So what do I have to do to the other side of the equation?
Add 49.
Okay, so now this is equal to 48.
All right.
Now how can I write what we just completed the square as?
Can't you write it as x minus 7 and then x plus 7, or is it just squared?
It's just squared always. In other words, the intent of completing the square is so that we can always write it as something that looks like that.
All right.
And the reason is that now we can solve the equation. If that's equal to 48, what's my next step for solving this?
Take a square root from
Okay,
both sides.
so what's the next line?
X minus 7 equals the square root of 48, which
Almost.
plus or minus the square root of 48? I don't know.
That's very important. That's one whole solution there. If you forget the plus or minus, you will lose points. So now what is x?
Uh, 7 plus the square root of 48, or plus or minus the square root of 48.
Okay, and
Square root of 48.
can I reduce that? Go through your perfect square numbers and see if any of them are factors of 48. Starting with 4. Yeah, 16, okay. So, what's that become?
So, 4 square root of 3. 4 square roots of 3.
Right. And notice that that looks just like an answer you would get if you had plugged this into the quadratic formula. And that's because it is. That's how the quadratic formula was discovered, or how it was worked out, was by completing the square. So it should look very much like the answers we would get had we plugged into the quadratic instead of completing the square. Okay? All right, let's do another one. Just make sure you got it.
X squared plus 18x plus 6 equals 0.
Okay, so we're going to take the 6 on the other side. Complete the square.
Plus 81. Plus 81's that side too, so.
Rewrite.
As like the factors, or yeah, so x plus 9.
It's always whatever you
Squared.
got when you took half of that middle term.
Yeah, squared. And then, yeah, 75.
Okay. Next.
And take a square root of both sides, so x plus 9 equals square root of 75. So
Almost.
3 and 25
Almost.
plus or minus the square root of 25 or 75. So 3 and 25. Yeah.
And then move the 9 over. You get that. Okay? Alright, so you know how to complete the square when x has a coefficient of 1. Do you have any completing the square problems where that coefficient is greater than or less than 1?
No.
Really? They're not going to give you
Yeah.
that level of difficulty. I'm surprised.
We're not supposed to use we're not allowed to use calculators on this test.
Well, you wouldn't need a calculator to do a problem like that. Okay, well, you know what's on your review sheet. So let's go to a different section. I mean, if you feel like you need more practice with completing the squares, let's do more problems there. But
no, I think I'm good.
seems like you got it if you remember the plus or minus.
Yeah.
If you forget the plus or minus, you're going to lose half credit on the point, on the problem.
Yeah.
Okay, so what next?
So it says write the expression as a complex number in standard form.
Okay.
And,
What's the
4i quantity, or 3 minus 5 I. 3,
like that?
yeah.
Okay. What's that equal to?
It doesn't equal to anything.
Well, in order to write it in standard format, we have to multiply it together and then simplify it.
Yeah, it's on my review sheet, it doesn't equal anything.
No, I know it.
Oh.
But your job is to simplify that, correct?
Oh, yeah.
Okay. So all I'm saying is what's the next step of simplification?
Okay. So multiply the 3 and the 5i by 4i.
Read the next line to me, Mitch.
Alright, 12i minus 20i squared.
Okay. And simplify that. What's I squared equal to?
-1.
Okay.
So -12.
Not -12. That's just I there. Here's the I squared.
Oh, wait.
So it's still 12i minus 20 times -1. Okay, now simplify that.
So 12i plus 20.
Okay, now put it in A plus BI format.
So 20 plus 12i.
That's it. A plus BI format. You need the real number first, and then that is the real number coefficient of the imaginary part. All right. What else? Let's do another one of those.
Parenthesis 2 plus 3i, and parenthesis, and beginning of the next parenthesis 2 minus 3i.
Okay, multiply those together. What do you get?
So 9i squared plus...
Hold on. We can do this two ways. We can FOIL it, or better yet, if you learn to recognize that you're looking at the difference of squares factored. Isn't that the difference of squares factored?
Yeah.
So how would you put it back together quickly, as opposed to the time it takes to FOIL it?
Wouldn't you just multiply?
Here's what we have. A plus B times A minus B. Well, I know that goes back together as A squared minus B squared because that's the difference of squares factored. So to do this quickly, it's 4 minus 9i squared.
All right.
Okay? And you have to do it so often that it's worth memorizing. It's worth noticing, because when you can put it together quickly, it takes about 10 seconds. When you have to FOIL it, it takes about 30 seconds. So any little shortcuts like that are going to benefit you immensely. What's 4 minus 9i squared equal to?
15?
Did you say 13?
No. Yeah.
Yes, correct. Okay. Now, when dealing with I, there's really only one tough problem. And that's division. Do you have one of those? In other words, multiplication is just like any variable. There's really no difference. You can treat I as a variable as long as you replace I squared with -1. But division is a little different. If I have this and I'm dividing it by this.
We have.
Okay, so tell me how to do this one. I'll give you one if you don't have one, because I know there's going to be one on your test.
Yeah. So would you multiply the top and bottom by -1?
No. The goal is to get rid of the imaginary number in the bottom. You cannot have an imaginary number in a denominator. It's not proper. It's like having an irrational number in a denominator. So how do we get rid of the I from the bottom?
Multiply it by the reciprocal.
No? Well, that's a clever thought. I kind of like that, actually. What would happen if we did that? That's not the right answer. Yeah, that gets rid of it on the bottom, and then I'd multiply that on the top, but notice that wouldn't help. In other words, it makes the bottom 1, but then when we multiply that together, we still have this I in the denominator. But I commend you on your creative thinking. It's just not right. Can you say the word conjugate?
Yeah.
What's the conjugate of 2 minus I?
2 plus I?
Yes. It's as simple as that. And notice why that gets rid of the I in the denominator, because that's difference of squares factored. So that's going to become 4 minus I squared, which is 5.
Right.
Okay, and then what do we have in the numerator?
Six plus I squared.
There's middle terms here. Those two middle terms only disappear when you're multiplying by the conjugates. When you multiply the conjugate, both those middle terms cancel each other out. But up here they add.
5I plus I squared.
Okay, now simplify all of that.
So the bottom's 3.
No, the bottom's 5. Remember, I squared is negative 1.
Oh, yeah. So 5, then so it would be 5 plus the square root, 5 plus 5 square root negative 1?
No. Here.
5I?
5 plus 5I. In other words, let's do it one step at a time. 6 plus 5I plus a negative 1.
Right.
Okay, don't worry about substituting for the I. Just substitute for everywhere you see an I squared. If you see an I cubed, you might want to substitute a negative I for that. But it's usually when you're turning in the imaginary number into a real number that we want to do it. Notice we turned this into a real number because I squared was equal to minus 1, and we're going to turn the top. So the top becomes 5 plus 5I all over 5, and simplify that for me.
So it's just 1 plus I over 1. Or 1 plus
1 plus I. Interesting. That turns into 1 plus I. You never can tell. These things are strange. But that's the only difficult imaginary number. If you're adding imaginary numbers, you add the real part, you add the imaginary part. If you're subtracting, same thing. If you're multiplying, you multiply it just like you'd multiply any binomial. It's only division that you have to remember to multiply by the conjugate. And to memorize that, think difference of squares. Always think difference of squares. That is the difference of squares factored. So I can immediately replace that with 4 minus I squared. Difference of squares.
So it's always going to be difference of squares when you divide by I?
Only in principle, because you're always going to multiply by the conjugate.
Right.
Okay? Even if you were doing this, if you were dividing that whole thing by just a minus I, just multiply by the conjugate, plus I. Notice how that turns in to minus I squared, which turns into 1.
Right.
All right. What else you got?
So I've just a solving problem.
Okay.
Y equals negative 3x plus 8. And y equals x squared plus 3x minus 8.
Okay. How do we solve this?
Can't you set them equal to each other, or
Yes, no, absolutely. If y equals that and y equals that, well, by the transitive property of algebra, this equals this.
yeah.
Because it's the same y.
Yeah.
Okay.
So it's just so you add 3x to both
Why don't
sides.
you read the next line to me? And I'll let you decide whether you want to do one step at a time or two steps.
So so 6x plus,
Okay, hold on before you go further. Are you moving everything to one side?
yeah.
Okay, then let's start out with the highest degree polynomial. Let's not start out with the 6x.
So x squared plus 6x plus, or minus 16.
Okay. And what's on the other side?
0.
All right. That's usually the first step we want to take whenever we're solving quadratics, particularly if they're going to factor nicely. Which this, so help me factor this. One step at a time, rather than all
X,
at once.
x and x.
Second step?
Are they different? Because
Yes.
it's,
The only way you get a negative 16 is if you have a plus times a minus, or a minus times a plus. You can't produce negative 16 if these signs are both the same. It would always be positive. So the moment you see a negative attached to the constant, that's step 2. Okay? Now what? What's the logic of the next step?
so you find two numbers that multiply to 16 that add together to equal 6.
Not add,
Subtract. So
because of that. If that was a plus, yes, it would be add. But it is whatever that sign is. In other words, if that sign is negative, then these factors of 16 have to subtract to the number 6. So what two factors would that be?
2 and 8
And where does the 8 go? With which sign?
on the positive
Right,
side.
because that's the sign of the middle term. So the largest factor has to go there. Because remember, we're trying to produce a 6x, and that's plus 8x, that's minus 2x, that's 6x. So we've done it properly. And what's the final solution? All of this equals 0.
So x equals negative 8 and x equals positive 2.
Okay.
More factoring problems.
Okay.
So 50x squared minus 20x plus 2.
It's the first thing I can do.
Could you divide everything by 2?
Yes, and you want to. In other words, that's part of factoring. So what's left over is this, whoops, is all I'm doing is, at the moment, factoring out a 2. I'm not dividing both sides by 2, I'm just factoring out a 2. Okay? Now, how can I factor that term? Goes here.
Could be 25.
Could be 25 and 1, but always assume that it's going to be the factors that are closest together.
So 5 and 5.
90% of the problems given to Colorado students are factors that are closest together. So always start there. Signs?
All right.
What is
Both positive.
No, they're both the
No.
same.
Oh, so both negative because it's negative 10x.
Exactly. And it better be 1 and 1, because that's the only factors of 1. Does that produce a minus 10x in the middle?
Yes.
Okay. Did this start out as an equation that we were supposed to solve?
No.
Just an expression we were supposed to factor?
Yeah.
Okay. Well, we've done it.
All right. That's all you need.
That's all you need, yeah. You would not want to multiply that 2 back. You would not want to give your answer like this, because that's not fully factored. I can take a 2 out. So always simplify it into its basic factors.
All right. So 2x cubed minus 3x squared plus 10x plus 15.
Okay. Cubics. At this level of algebra, for you to be able to solve a cubic, it has to meet certain criteria. Has to lend itself to grouping. Does this?
No.
Actually, it does, and it has to, because otherwise you would not be able to solve it. She's not going to give you this problem, because she hasn't taught you how to solve that problem yet. That's pre-calc to solve that problem. But, so no going in that, yes, grouping is going to work here. Okay, and you always group those 2 terms and these 2 terms. And let's see what we get here.
I don't really know how to group.
Well, I see why you said no. You sure you did you read the problem to me correctly?
Yeah.
It's minus 3x squared and it's plus 15?
It's minus 10x.
Ah, that makes a huge difference. Now it lends itself to grouping. In other words, what was the ratio of the coefficients? It was minus 2 to 3, right?
Yeah.
What is the ratio of these coefficients? Minus 10 to 15. That's the same ratio.
Yeah.
That's what you need to be able to group, is that ratio has to be the same. Now notice when it was plus 10x, it's not the same. We have a minus 2/3 over there, and we have a plus 10/15 there. We would not be able to solve this if that was a plus 10. So it's still not automatic. There's still one trap that you have to negotiate here. So group everything for me in parentheses and tell me what you get.
So it should be x, or 2x cubed minus 3x squared
That parentheses isn't particularly needed, but we're going to use it anyway because we're going to then factor a greatest common factor out of that. This is the step that everybody screws up. What goes over here?
10x plus 15?
Now, is that the same thing you started with?
No.
Then it's not the answer.
So, minus 15 because you took a minus out?
Exactly. In other words, you have to end up with the same thing you started with. Always do this check to make sure that that is equal to that. And it is. But 90% of my students get the sign wrong right there. So that is the big trap when you're solving these. It's not knowing that you have to group. We know that we're going to be able to group them, otherwise the problem wouldn't be on the test. It's how you do it that's important. And part of the process is to group with these parentheses. So you know you're going to have to put parentheses around these two terms. And the moment you do that, you have to be careful of that sign right there. Okay, now factor a greatest common factor out of each thing.
So the greatest common factor of the first one would be just x squared. So 2x minus 3. The greatest common factor, that's 5. So 2x minus 3.
Now the only reason this works is because that is equal to that. If this came out to be 2x plus 3, we could go no further. The fact that it's the same term as over here means now what can I factor out?
2x minus 3.
In parentheses. And what's the rest of it?
X minus 5.
X squared minus 5.
Oh yeah, x squared minus 5.
Okay. Now, I don't know whether your teacher wants you to go further than that or not. That is the difference of squares, and it could be written as x minus square root of 5 times x plus square root of 5. In other words, they've really been lying to you this whole time. It doesn't have to be difference of perfect squares. Any difference of squares factors into the square root of that minus square root of that and the square root of that plus square root of that. But like I said, I don't know if your teacher wants this as the final answer or would settle for that. It's probably settle for that, since they do tend to teach you difference of perfect squares, and they don't apply the difference of squares until you get to calculus or something. Okay?
All right.
What else?
Let's just switch to just solving.
Okay.
So 14x squared plus 11x plus 3 equals 2x squared minus 3x plus 3.
Okay. Read the next line to me.
12x squared plus 14x equals 0.
And the next line.
What do you do again?
Well, what can I do? Always, whenever you're trying to solve a quadratic, always start with, can I factor a greatest common factor out? Most of the time you can't. In other words, if there's ever a constant, you can't do it, because this thing doesn't have an x in it. But if you're missing a constant, you can always do it. So let's factor a greatest common factor out.
2x. So 6x plus 7 equals 0.
Solution?
So I don't know.
Okay. The most fundamental principle of algebra is the principle that says if you multiply two numbers together and equal 0, then one of them has to be 0. You can't think of two numbers that multiply together to be 0. You can add two numbers to be 0, but you can never multiply two numbers to be 0 unless one of them is 0. So that's how we solve all quadratics, is we get it down to this step where we have two things multiplied together equaling 0. That allows me to say what?
X is equal to 0.
Okay. 2x actually, but that makes x equal to 0. Or always look for the or when you're doing a quadratic, because you almost always have two solutions.
Or x is equal to 7? No.
Or 6x plus 7 equals 7.
Oh. Okay.
Solve that.
6x equals negative 7. So x equals 7 over 6, negative 7 over 6.
Okay. There's your two solutions.
All right.
All right.
So x squared plus 4x equals negative 9.
Okay.
So would you move the negative 9 to the other side, so it'd be x squared plus 4x plus 9 equals 0?
There's a couple of ways you can do this problem. That's probably a good first step, because at this point we don't know if we can factor it yet. Can we factor it?
No.
No. There's only factors of 9 are 9 and 1 and 3 and 3, and neither one of them are going to produce this as a middle term. So we got two choices at this point. What are they?
Quadratic formula, or
That's number one.
California method?
No, the California method isn't going to help you factor this either. The California method only gives you factors that I could get by my method. I can plug it into the quadratic formula, or I can go back up here and treat it as complete the squares. It depends on which you find easier. You're pretty good with the quadratic formula, aren't you? Don't you know that by heart?
Yeah.
I would suggest doing that, although given the fact that you have to do completing the squares, might be good practice to do that. What do you think? I mean, we started off. I know you had it. I know you know how to do the quadratic formula. So let's not practice something that you're good at. Let's practice something that you're not quite sure at. So if the very first problem you gave me tonight was complete the squares. So let's do it here. First of all, let's give ourselves room Okay.
Alright. So you divide 4 by 2 and then square it, so you would add 4 to both sides. And it'd be x plus 2 squared equals -5. And square root of both sides, so x plus 2 equals the square root of -5. Plus or minus the square root of -5. Two plus or minus.
Get your sign right.
Yeah. -2 plus or minus the square root of -5.
Now, at this stage, we're at the final stage of where you would have gotten if you'd have plugged it into the quadratic. It wouldn't even be this simplified yet. So that's 1, 2, 3 steps. Plugging it into the quadratic is going to be 1, 2 steps. So the quadratic is a little bit more efficient, but personally, I don't know. I mean, it's really up to you as to which one you like better. Now, give me the final simplified answer in complex format.
Would be square root of 5 high?
Yes. In other words, the square root of -5, the way to always do these is immediately factor out that, leaving behind that. Because this is what you're going to replace with I. Okay?
Yeah.
Okay. So that wasn't too bad. I think you do completing the squares pretty good, but you do the quadratic pretty good too. So I guess if you're taking a test, choose the one that you're most comfortable with.
All right.
Just remember that when you do the quadratic, you're always going to end up with that 2a underneath. And then you have to, in other words, in the last problem, we would have ended up with something that looked like this. After plugging into the quadratic formula, this is what we would have gotten. And then this has to be reduced to that. Okay?
Yeah.
All right.
So 1/2 parentheses x plus 3 squared equals 5.
Okay. What's the simplest way to solve this? There's also like 3 different ways to solve this. But there's one way that is particularly straightforward, simple, and by far the quickest.
So there's completing the square quadratic formula.
Hold on, stop a moment. You complete the square in order to make something look like that.
Oh.
This already looks like that. That's why it's so straightforward. In other words, the reason you complete the square is so that you can get to this step and then take the square root of both sides. That's what's the beauty of completing the square. Well, we already have it here. So the one thing we don't want to do is expand this. That just makes the problem harder.
All right.
When we complete the square, we end up with something that looks like that all by itself on the left side of the equation, right?
Yeah.
So let's get this there. In other words, the goal when you have something like this in an equation is always to isolate it. We want to isolate that because once we isolate it, we can take the square root of both sides.
All right. So you just multiply both sides by 1/2.
If I multiply the left side by 1/2, I'm going to get 1/4.
So the reciprocal.
The way to think about this, Mitch, is that right now the 2 is dividing that. So to get rid of it, I got to multiply by 2. In other words, whatever you need to do to get rid of this 1/2, I could say, well, I'll divide by 1/2. That'll do it. And I would be correct. It's just a difficult way of looking at it. Because now I'm dividing a fraction by a fraction. That confuses a lot of people. So rather than do that, let's multiply. Let's treat this as if it looked like that. Now, if this was the problem, I'm quite sure your first step would be multiply both sides by 2, right?
Yeah.
Well, remember that when there's a 1/2 out there, that is the same as this. Okay, what next?
Square root of both sides. So x squared plus 3 equals the square, plus or minus the square root of 10. X equals the -3 plus or minus the square root of 10.
Good, that's it. Now,
Okay.
see, that was 1, 2, 3 steps. And I can tell by looking at the answer that if I were to expand that and bring everything over on one side and try to factor it, it's not going to factor. Because when you get irrational answers like that, it's always a not going to factor problem. So we could spend a lot of time looking at this problem from some of those other angles and waste a lot of time. We'd always have to come back to the middle or go to the quadratic formula or something more complicated. So whenever you see that, know that you are 2 steps away from solving it.
All right. I don't think I have any more that I need your help on.
Okay. Yeah, that's fine. You sure? You want to take one last look through your packet and see if there's any there that you're not 100% sure you know how to do? Is there any word problems?
No, there's like absolutely very little words except when it says like, just like what to do.
That's a good thing. That's a good thing, actually. At least I always love that. If you give me a math test that has nothing but problems, I'm going to ace it. The only things that even come close to giving me difficulties are those word problems that can be challenging. So
yeah.
All right. So what else? What final one would you like?
Try one of those ones that you have the I in the denominator.
Okay, good. That's a good one to try.
So 1 minus 2i divided by 3 minus 5i.
Okay, first step.
Multiply both top and bottom by 3 plus 5i.
Okay. What's the bottom become?
9.
Remember, we're looking at difference of squares that have been factored. So it's got to go back to a difference of squares. In other words, if I show you a minus b times a plus b, what is the answer to that? I can immediately write a squared minus b squared.
All right.
So do the same thing to these two terms. 9 is the a squared. What's the minus b squared going to be?
25 I
What's I times
I squared, so
Notice what that is. It's this term times itself.
all right.
So this b squared always has to be this term, not with the minus sign, times that term. Then you know it's the difference of squares, so there has to be a minus sign in between. Okay. Now, perhaps I'm emphasizing that too much. You could always FOIL that together to get this. It just takes a lot longer. So I'm trying to get you to recognize these shortcuts.
All right.
Okay. Now the top you have to do the long way. What's the top?
3 plus 5 minus, so plus 1, or minus 1, or I mean, plus, no, minus 10I.
Don't forget the I squared.
Squared, yeah.
And the reason is that we're always going to turn that into a real number. So this last number you get is always I squared, just like the bottom is always I squared. Whenever you're multiplying these conjugates, you've always got an I times an I as the last part of the FOIL. Okay.
Yeah.
Okay, now simplify the top.
3 minus I. Oh no, so I squared, so plus 10, so 13I, or 13 minus I equals 34.
Okay. Now, is that in A plus BI format?
No.
Okay, let's put it in A plus BI format.
So it would be 13 over 34 minus I over 34.
Still not in A plus B format.
I don't.
How about 13 over 34? What is B? B is 1/34th I.
Oh, yeah.
Okay? In other words, A plus BI, you got to come up with B. We didn't have a B here. B needs to be written separate from the I.
All right.
Okay?
Yeah.
All right. And these always unfold the same way. In other words, you always end up adding the two numbers on the bottom. In other words, when you have 9 minus 25I squared, with practice, you recognize instantly that that's going to be 34. And that this number is going to add to that number. So the pattern is always the same. You end up with an I squared in top and bottom. So look for that I squared. That's the whole reason we do that. That's the whole reason we multiply by the conjugate, is so that we can produce that I squared.
All right.
What else?
So I'm going
to... Let me make one up for you, because this,
right.
This can give some people a little bit of difficulty.
So you just multiply both top and bottom by negative I.
What's the top become?
Two or negative 2I, or would it be negative 2I times or minus I squared.
What is that times that?
Positive I squared.
What's the bottom?
I squared. Negative I squared.
Simplify the top.
Negative 2I minus 1.
Okay, let's write it in the proper order.
Negative 1 minus 2I.
And what's the bottom?
I. Or 1.
So that's the answer.
Alright.
In other words, even if you don't have a real part to the bottom, the conjugate of I is negative I.
Okay.
All right. Any last questions, or are you good to go? We still got a few minutes if you have any more you want to look at.
Let's try another one of those.
Okay.
So 7 minus 4I over 2 plus I. So multiply both top and bottom by 2 minus I. So you get 4 minus I squared on the bottom, and 14 and so, and you get 13I minus 13I.
It's interesting that we both made the same mistake in our head. How did that happen? Ah, you did the same thing I did. Wow. That is really strange. As I was sitting here thinking about multiplying the top together, I got 13I. And then I realized, no, that's not right. And then that's what you got. How did we both make that mistake?
I don't know.
What is it should be? What's 4 times 2?
8.
7 times 1.
7, so 15I. Alright.
That is amazing that we both made that error. Okay,
Yeah.
the rest of it?
Minus 4I squared.
Minus times a minus. Don't forget your algebra. In other words, I can see why you're doing that mistake. Is you're getting ahead of yourself in your thought. Yeah. You're already converting the I squared to a minus 1 before you get to that step. So make sure you multiply algebraically properly.
Yeah.
That is plus 4I squared. Don't do the conversion to minus 1 until you're done with that step.
Yeah.
Now what?
So now it's on the bottom, it's just 5. And then so it's 10 minus 15i.
Okay, now give me that answer in A plus BI format.
So it's 2 plus 3i. So 15 over. So it would be
It's not plus.
negative.
It's not
So
plus.
it'd be,
2 minus 3i.
yeah. Right.
Okay?
Yeah.
All right. I think you're good to go.
Right.
I think you know it. There's some hesitancy quite a bit, and
Yeah.
that can translate into mistakes when you take the test. But the best way to get around that is practice. You said you had a huge review packet, so you probably have more problems that you could practice on. And
Yeah.
I would suggest you do it, just to get yourself comfortable in that process, especially with the eyes.
All right.
Okay? All right, Mitch, I'll talk to you next Saturday.
All right.